Settle in and let your breathing slow, because tonight you are following a river that never seems to make up its mind. The air is warm, the sky is heavy with stars, and somewhere in the reeds, frogs keep time like a soft, steady metronome. You think a river is supposed to hurry, to choose a direction, to deliver itself to the sea, but here, in the Okavango Delta, water spreads out and lingers. It slips into side channels, disappears into grass, and returns again, as if the land is quietly teaching it patience. Stay with the Sleepless Geographer, and we will drift through strange, gentle places like this, where Earth behaves oddly and does it very, very slowly. You are low to the water now, close enough to feel its coolness rise into the night air. The surface looks black at first, like poured ink, but when starlight catches it, the river shows its real texture: soft ripples, slow turns, and floating strands of green that move like hair in a bath. And this is the first quiet trick the Okavango plays on you. You expect a river to be a line, a simple promise. Water goes this way, land stays there. But the Okavango arrives, takes one look at the flatness ahead, and forgets how to be a line. It becomes a wide, patient maze. It becomes a place where water spreads out and rests. The soundscape is simple, which is one reason it feels so big. Insects buzz, then stop. Reeds click against each other as if the wind is turning pages. Something splashes in the dark, probably a fish, possibly something with teeth. And you do not need to solve that mystery tonight. You just need to notice how the delta is shaped, not like a spear, but like a fan. It opens out across the land, slowly, as if the river is exhaling. And as your eyes get used to the dark, you start to notice the real shape of the delta, not a line, but a gentle fan of water opening across the land. Most deltas are coastal creatures. They are the final, tired gesture of a river meeting the sea. The Nile does it. The Mississippi does it. They bring their mud and sand to an ocean, and they build a soft, spreading triangle at the edge of salt water. But here, you are standing in a delta that never gets that ending. The Okavango Delta sits inland, far from any coastline. There is no ocean waiting at the end, like a reward. There is only sand and sun and a kind of slow disappearance. The river comes in, generous and steady, and then, without drama, it simply fades into the Kalahari. You can picture the journey backward, the way a tired mind rewinds a story. Far to the north, in the highlands of Angola, rain falls in seasons that feel distant from this warm night. That rain gathers into streams. Streams collect into larger rivers, and eventually, the Okavango begins its long walk southward. It carries a little bit of that highland world with it. Not just water, but fine grains of sediment, bits of plant matter, dissolved minerals, the small, invisible ingredients that make wetlands smell like life. By the time the river reaches this basin, the land is so flat that the difference between moving and stopping is almost a philosophical question. The water spreads because it can. It spreads because there is no single channel deep enough to boss it around. And then the air begins its quiet work. Heat is not just a feeling here. It is a process, a patient thief. Under the sun, water turns into vapor and rises, molecule by molecule, back into the sky. Evaporation is so ordinary you barely notice it, which is exactly how it gets away with everything. Plants help too, in their own calm way. Reeds and grasses pull water up and release it through their leaves. This is transpiration, an official word for something that feels like the land sighing. So the delta lives in a balance that never announces itself. Water arrives from far away. Water vanishes into air. Some of it sinks into sandy ground. Some of it lingers in channels and pools long enough to make this place feel impossible. And somehow, year after year, the system keeps breathing. If you stay with that idea for a moment, it becomes oddly comforting. This is not a place that needs an ending. It does not need to reach the sea to be complete. The delta is not a failure of a river. It is a different kind of success, one that measures time in seasons, not in destinations. But the delta is not just water disappearing. It is also water choosing paths, splitting and rejoining like a slow conversation across the floodplain. So you let yourself drift into one of the channels, the narrow ones, where the reeds rise high and the air cools by a few gentle degrees. Here, the water feels more like a corridor than a flood. It slides forward with a softness that makes you doubt it is moving at all. Papyrus leans over the edges, thick and green, like the river is being carefully tucked into bed. Some stems creak when the breeze shifts. Others are perfectly still, as if they are listening. These channels are shaped by very small differences in height, not cliffs, not hills, just the slightest tilt in the land. A rise you would not notice on foot, a dip you could step over without thinking. But water notices everything. Water can feel a slope the way your hand can feel a wrinkle in a sheet. It follows the easiest whisper of downhill. And in a place this flat, those whispers are faint, so the water takes its time deciding what they mean. Sometimes, a channel splits into two, and both paths look equally reasonable. The river does not panic. It does not choose like a person chooses. It simply flows and keeps flowing, and the landscape takes care of the rest. One branch might carry more water this year because a fallen tree nudged the current. Another branch might dry a little because reeds grew thicker and slowed it down. The channels adjust with the calm persistence of things that are not trying to meet a deadline. And then there is the flood, which is the delta's slow clock. Every year, water arrives in greater volume, but not with the kind of sudden violence you might imagine. It does not roar in like a wall. It creeps. It advances into grass. It fills low places first. It turns dry ground into sponge, then into shallow lake. The changes are gentle, but they are complete. A place that was dusty and pale becomes glossy and green. The horizon does not move, but the world under it rearranges itself. And because the flood moves slowly, it does something very strange to your sense of time. You stop thinking in hours. You start thinking in stages. The water is here now. It will be there later. It will be gone eventually, and then back again. If you lived here, you would learn to read these stages like a calendar written in mud and reeds. But even as a visitor in the dark, You can feel the logic of it. Water arrives, spreads, rests, and then retreats, leaving behind little changes that will matter next year. And when the floodwater spreads out, it does not only fill channels, it paints the land with temporary lakes, and that is when the islands begin to matter. In the moonlight, islands in the Okavango can look like shadows resting on the water. Not mountains, not dramatic things, just slightly higher places where the flood does not fully take control. Some islands begin as accidents. A small pile of sand, a tangle of plant debris caught on a root, a place where the current slowed just enough to drop what it was carrying. Over time, those small piles become obstacles, and obstacles become collectors. More sediment gathers, more plant matter catches, and slowly an island is born, the way a pearl is born, by layering patience onto irritation. And then there are the termite mounds. They do not look like much at first, especially in the dark. A rounded rise, a lump of earth. But termite mounds can become the first reliable high ground in a world of shallow water. Termites bring soil up from below, grain by grain, and they build structures that can last for a very long time. Long enough for seeds to land, long enough for roots to hold, long enough for a patch of slightly higher earth to become a home for trees. You can imagine the first tree that gets lucky here. A seed drifts in on water, or rides the wind, or falls out of something's stomach. It lands on a mound that stays dry just long enough. Its roots find moisture nearby, but its trunk stays above the flood. Once a tree grows, it changes everything. Shade cools the ground, leaves fall, and create soil. Birds land and drop more seeds. The island becomes more island-like, more stable, more layered. In the day, these islands become resting places for animals, for people, for your own mind, if you let it wander there. They are cool, dim refuges in a bright wetland that can feel endless. At night, the islands are quieter. They hold the smell of dry wood and warm bark. You might hear something moving in the brush. Again, you do not need to investigate, and the sound fades into the reeds. But islands do not just rise above water. They also change the water around them. Currents split and curl. Fine sediment drops out. Minerals concentrate at the edges. The island becomes not just a place, but a small machine shaping the delta one slow season at a time. And around these islands, something subtle happens. Salt and minerals gather where the water leaves, creating patterns that look almost like the land is quietly writing to itself. In the morning, if you were to see it, you would notice pale edges around certain pools, lighter soils, thin crusts that look like someone dusted the ground with flour. The first time you see it, you might think it is just dry mud or sun-bleached sand, but it is the ghost of water that used to be there. When water evaporates, it does not take everything with it. It leaves behind tiny traces, dissolved salts and minerals that were carried in quietly from far upstream. One flood does not leave much, but the delta has had a lot of floods, and it has had a lot of time. So over years, and then centuries, certain areas become more mineral rich. In the outer parts of the delta, where water spreads thin and disappears fast, the concentration can grow. Some pools become a little salty as the dry season deepens. Some flats become places where only certain plants can tolerate the chemistry, and that creates a gentle contrast in the landscape. Fresh channels nearby, lined with green, and farther out, pale patches that shimmer in heat, as if the delta is slowly turning into a different planet at its edges. It is not a harsh boundary. It is a gradient, which is a soothing word for a real and complicated truth. The delta is not one habitat. It is many habitats stitched together by water that cannot quite decide where to settle. If you were here in daylight, you would see how the color changes. Deep green where water stays, yellow grasses where it comes and goes, pale soil where it mostly leaves. At night, you feel the same contrast in temperature. The air over open water stays a little warmer. The air over dry ground cools faster. You drift through invisible layers as if the delta has different rooms, each with its own quiet climate. And the longer you sit with this, the more you realize the delta is not only shaped by water arriving, it is shaped by water leaving, which brings you to the delta's biggest secret, its timing. Speaking of the season drying out, the delta's biggest secret is its timing. The flood arrives late, like a letter delivered months after it was sent. Rain falls far away, in the upper parts of the Okavango's basin. It falls in a season that has its own storms, its own rhythms, its own thunder. And then it begins to move slowly downstream. But rivers do not deliver water the way a pipe delivers water. They deliver it the way a rumor travels through a crowd, delayed, reshaped, slowed by every bend and floodplain. The water has to pass through channels. It has to spread and soak into low areas. It has to pool and then spill onward. It has to negotiate vegetation and sediment and the gentle stubbornness of flat land. So by the time the flood arrives in the Okavango Delta, the local skies might be doing something completely different. You could be sitting under clear weather, breathing warm, dry air, while new water quietly slides in, fresh from distant rain. It is a strange experience. The first time you really understand it. The flood is not responding to what you see overhead. It is responding to what happened months ago, far away, in a place you might never visit. That delayed arrival creates a dependable rhythm, not perfectly predictable, because nature enjoys improvisation, but steady enough that life can plan around it. Plants time their growth. Fish move into newly flooded areas. Birds arrive when feeding becomes easy. Even large animals, in their own practical way, follow the water's schedule, because the water is the schedule. And for you, lying here with the night sounds pressing gently against the edges of your attention, that delay can feel like a lesson in patience. The world does not always answer immediately. Sometimes cause and effect are separated by long, quiet travel. The delta becomes an enormous reminder that distance matters, time matters, and that what feels like a sudden change is often the end of a very slow journey. You can almost imagine the flood as a traveler, tired and steady, arriving late to an appointment it never forgot. It does not rush when it gets here. It spreads out like someone finally taking off a heavy bag, setting it down, and deciding to stay a while. And once you have felt that slow rhythm, it becomes easier to zoom out, because the delta sits inside a much larger story of basins, deserts, and places where water does not get an easy exit. The Okavango works because the land holds it, not with walls or cliffs, but with shape. The region around you is part of the Kalahari Basin, a broad, shallow bowl, a landscape that does not give water a clear downhill path to the sea. The sand here is porous, which is a polite way of saying it is thirsty. Water can sink into it, slipping down into underground spaces, stored out of sight. Some of that groundwater may stay for long periods. Some may move slowly, like a second hidden river. On the surface, the Kalahari can look empty, especially when you are far from the delta. Open horizon. Sparse as trees, soil that seems to drink whatever it touches, and then, almost improbably, this wetland exists inside it, like a green thought in a dry mind. That is one of Earth's calmer jokes. People tend to imagine deserts and wetlands as opposites that cannot share a neighborhood, but geography is not built from neat categories. It is built from overlaps, from exceptions, from places where conditions line up just right and something unexpected persists. The Delta is one of those places. It is a wet bloom in a sandy country, supported by distant rain and slow land. A reminder that what matters is not just how much water falls, but where the land allows it to linger. And the land here does more than linger with water. It rearranges it. You can feel it in the way that channels behave, like they are politely avoiding commitment. A corridor of water bends, narrows, and then, without warning, it just becomes a sheet, not a dramatic lake, not a deep bowl, just a thin, shining layer over grass, spreading the way spilled tea spreads across a tablecloth. That is the Kalahari's gentle grip. It does not dam the river with rock. It holds it with flatness, with sand, with the simple fact that there is no obvious escape route. If you walk out from the darker channels toward the edges, the ground under you changes texture. It stops feeling springy and starts feeling powdery. The sand is not beach sand. It is older, quieter sand, the kind that has been moved around so many times it has forgotten where it came from. And congratulations, you are standing on a landscape that is still deciding what it wants to be. The Kalahari is not a single desert the way a postcard would prefer. It is a huge basin with a complicated history. Some parts are grassy, some are scrub, some are salt pans that glare white in the sun. But underneath all of it is a broad idea. Sand, spread over time, accumulating in a shallow bowl. That bowl is why the Okavango can bloom at all. In a steeper place, water would cut a channel and flee. Here, it arrives, spreads, and then the ground and sky quietly take their share. You do not see the bowl like you see a crater. You feel it the way you feel a room that slopes so slightly you only notice when a marble rolls. The delta sits in a low part of southern Africa's interior, not the lowest point of the continent, not even close, just low enough and flat enough to make water hesitate. And that hesitation is everything. Some of the water disappears straight upward. Heat and wind lift it into the air. Some of it disappears downward. It seeps into sandy pores and tiny gaps, turning the ground into a slow sponge. That seepage is not a loss. Exactly. It is storage, just not storage that looks impressive. Underground, water moves in lazy, almost unmeasurable ways. It does not surge. It drifts. If you could watch it, you would be bored within seconds, which is a compliment in geology. In places, that groundwater can reappear. It can feed other wetlands. It can emerge as a seep, a damp patch, a line of greener vegetation that looks like the land is leaking a secret. But most of it stays hidden, held in sediment, like a long memory. And you start to understand something slightly unsettling and strangely calm. The delta is not just water on the surface. It is water in layers, surface pools, soaked soils, underground reserves, and then the sky itself holding vapor that might become rain somewhere else. A wetland is not a place. It is a process. Humans, of course, prefer places, prefer borders, prefer lines on maps that say, this is where the wet ends and the dry begins. But here, the edge of the delta shifts like a thought you cannot hold on to. A year with more water pushes the wetness farther out. A year with less water pulls it inward. Even within the same year, the boundary breathes, expanding, contracting, leaving behind damp ground that dries into cracked patterns. Those cracks are small, but they are honest. They tell you that the wet and the dry are taking turns. And it is in those in-between zones, those places that cannot decide, that some of the strangest textures appear. A patch of grass that looks ordinary until you step and realize the soil beneath has a faint crust, a depression that holds water for a few weeks, then becomes a pale, dusty pan. The mineral story is slow, but it is persistent. Water arrives carrying tiny dissolved bits of faraway rock. When the water leaves, the bits stay. In channels where flow continues, those dissolved minerals keep moving. But out on the fringes, where water spreads thin and evaporates fast, the minerals accumulate. It is like making soup and never washing the pot. Eventually, the pot remembers everything you ever cooked. So the Kalahari does this gentle sorting. It allows freshwater corridors to exist near slightly salty margins. It makes a mosaic out of chemistry and patience. If you listen closely in your mind, you can hear how that shapes life without needing any drama. Some plants avoid the salty ground. Some tolerate it, even prefer it. Some animals follow the fresh channels because they are sensible. Others come to the edges for minerals, for grazing, for the particular mix of open space and shallow water. And you are just moving through it, quietly, watching the geography do its work without asking for applause. If you could take a long view, longer than a human schedule, you would see the delta itself shifting across the basin over centuries. Channels clog with vegetation and sediment. Then the water finds a slightly easier route. Old channels dry, new ones open. The fan shape subtly redraws itself. The land does not care if your favorite lagoon is gone next decade. It is not sentimental, but that is the comforting part too. The system is not fragile in the way a glass ornament is fragile. It is resilient in the way a rumor is resilient. It changes shape. It migrates. It continues as a pattern even when the details move. And when you accept that, you can let your thoughts loosen their grip on neat expectations. Because if a wetland can exist inside a sandy basin, then there are other places where water behaves strangely, quietly breaking the rules you thought were universal. So you leave the warm interior night and you travel west in your imagination, toward a different kind of edge. Not the edge between wet and dry, but the edge between ocean and desert, where the air itself becomes the delivery system. The first thing you notice is the temperature shift. The land is still dry, still sandy, still stingy with rain, but the air rolling in from the sea is cool enough to raise goosebumps on skin that has been thinking it lives in Africa's heat. It is early morning on the Namib coast, and the world is the color of unpolished metal. The ocean is there, but you do not see it clearly. Fog has arrived first, spilling over dunes like a slow tide made of breath. You think fog means wet ground. Wrong. The sand stays dry because fog does not behave like rain. It does not fall with force. It does not soak deeply. It just touches things, slightly, repeatedly, leaving tiny droplets on every surface, patient enough to collect them. The Namib Desert is old. Not just old for a desert, old in a way that makes your sense of time feel silly. It has been dry, in some form, for millions of years, and yet, beside it, the Atlantic keeps sending this cool, gray gift. This is where geography shows off without raising its voice. Out in the ocean, a cold current moves along the coast. Cold water chills the air above it. That chilled air cannot hold as much moisture, so water vapor condenses into fog. The wind then carries that fog inland, often at night and in the early morning, letting it creep across dunes that have not seen meaningful rainfall in a long time. So you are standing in a place where the ocean feeds the desert, mostly through mist and inconvenience. The dunes rise around you like sleeping animals. Their curves are smooth but not soft. The sand is fine and it shifts underfoot with that whispering slide that makes every step feel temporary. Fog beads on your eyelashes. It dampens your hair. It makes the soundscape smaller. The world is quieter in fog, as if the air is padded. And here is the odd part. You can be surrounded by moisture, breathing it in, feeling it cling to your skin, and still be in a landscape that is fundamentally dry. The fog is not enough to refill aquifers or feed rivers. It is just enough to support small, stubborn lives that have adapted to this strange arrangement. You see it in the posture of plants. They do not sprawl. They do not waste effort. They hunker down, armored against evaporation, built to hold on to whatever the air offers. Some plants collect fog directly. Leaves, spines, and ridged surfaces act like nets. Droplets form, grow heavy, and finally slide down toward the roots. It is not a flood. It is not even a drizzle. It is a slow, repetitive sip. And if you get close to the ground, closer than you would prefer, because sand is not known for hospitality, you notice tiny tracks and small burrows. Creatures here have learned to live on little. They move in cool hours. They hide in the day. They are experts at not being noticed. The dunes themselves are mobile, which is another polite way of saying they will eventually cover whatever you build. Wind pushes grains up the gentle slope of a dune, and gravity lets them slide down the steep side. Over time, the whole dune migrates, like a sand creature crawling. If you stay long enough, you start to hear the wind shaping the desert in real time. Sand grains tap against each other. A thin veil of particles skims across the surface. Sometimes a gust lifts a sheet of sand into the air, and the dune briefly looks like it is smoking. Congratulations, you found a landscape that is constantly moving and still manages to look calm. Fog makes it feel even stranger. The gray air flattens distance. Dunes fade into each other. The horizon dissolves. You could walk in a straight line and not realize you have been subtly redirected by the shape of the land. This is how deserts get away with being dangerous without looking threatening. But there is a rhythm here too. Fog arrives, then burns off as the sun climbs. The desert becomes brighter, harsher, more honest about its dryness. The temperature rises. The air becomes sharp again, stripping moisture from anything exposed. So life has learned to use the morning. It drinks quickly, then retreats. And when you step back from the coast in your mind, you can see the larger pattern. On one side, a cold current hugging the continent, keeping the air cool and stable, discouraging rain. On the other side, dunes and gravel plains, absorbing heat, creating an atmosphere that wants to evaporate everything it touches. Between them, fog, an in-between state, neither sea nor sky, delivering water in the least efficient way possible. And yet, it works. Just barely. This is one of those geographical contradictions that makes you stop trusting your first assumptions. Ocean nearby does not guarantee rain. Moisture in the air does not guarantee wet ground. You can have water everywhere around you in vapor and droplets and still be thirsty. Humans have always tried to solve that with technology. Wells, pipes, desalination, reservoirs. On this coast, towns survive because ships can arrive and because infrastructure can import certainty. But the desert itself does not negotiate. It offers fog and expects you to adapt. If you wanted to live here without modern help, you would learn quickly that the desert is not empty. It is simply minimalist. It does not provide excess. It provides enough if you are careful and if you accept the schedule. And schedules are really what this whole night is about. In the Okavango, water arrives late, as a delayed flood. Here in the Namib, water arrives early, as fog, and then vanishes again by midday. Different mechanisms. Same lesson. The planet is not trying to please you. It is just running its systems. And speaking of systems that do not care about your comfort, there is a form of water that is even less interested in being convenient. Because fog is gentle. It touches the desert softly. Ice does not. So you let the fog dissolve behind you, and you travel north in your imagination toward latitudes where the air bites instead of clings. The sound changes first. The soft hush of fog is replaced by a kind of clean silence, the silence of cold places where insects are not performing for you. You arrive at the edge of a glacier without fanfare. It is not a sparkling blue movie scene. Up close, glacier ice is often dusty, streaked with grit, scarred by embedded stones. It looks like frozen time that has been dragged across the ground. You think ice is still. Wrong. A glacier is a river that forgot how to be liquid. It flows anyway. It flows so slowly that your eyes cannot catch it in motion, but your bones could if you waited long enough. The ice deforms under its own weight. It creeps downhill, guided by gravity the way water is, just with more stubbornness and far more patience. You stand near a crevasse and the world feels suddenly hollow. A crack opens in the ice, deep enough to swallow light. The edges are sharp, and the blue down inside looks unreal, like the color belongs to a different planet. That blue is not magic, it is density. Thick ice absorbs many colors of light and lets blue scatter back to you. It is physics wearing a beautiful mask. And then the glacier speaks. Not with words, obviously, with sound. A low creak, like a ship settling in water. A sudden pop, as stress releases somewhere beneath the surface. Sometimes a distant rumble, as a chunk of ice fractures and collapses. The glacier is always adjusting, always cracking, always healing itself by refreezing. If you want cozy geological horror, this is a good place to find it, because everything here looks stable and everything here is under stress. The glacier is heavy enough to press down on the land beneath it. The rock below is not unbreakable. Under the weight of ice, the ground can sink slightly, like a mattress under a body. And when the ice retreats, when climate shifts, when seasons change, when centuries add up, the land can begin to rise again. Isostatic rebound, it sounds like a piece of office furniture. It is actually the crust lifting back up after being crushed for thousands of years. You do not feel it day to day, but it changes coastlines over time. It changes sea levels locally. It changes where rivers choose to run. Even after ice is gone, the land keeps responding, like a bruise slowly fading. Now, you follow the glacier downhill to where it meets rock and soil. This is where the glacier becomes a worker, not just a presence. At the base, ice grinds against bedrock, dragging stones like sandpaper. It scrapes valleys wider and deeper. It smooths ridges. It plucks blocks of rock loose and carries them along, embedded in the ice like teeth. The result is a landscape that looks carved rather than eroded. Rounded hills, polished surfaces, long grooves scratched into rock, pointing in the direction the ice once moved. You can run your hand along those grooves and feel the glacier's handwriting. And when the glacier finally melts back, it leaves a mess. Not a clean retreat, a scatter of debris called moraine, piles and ridges of rock and sediment, dumped where the ice paused or ended. It is like a moving company that never bothered to unpack, just dropped everything in a heap and left. Water then gets involved, because meltwater pours from the glacier's edge, cloudy with rock flour, that fine sediment ground from stone. The stream looks milky, like someone stirred chalk into it. That is literal ground rock, on its way to becoming soil somewhere downstream. Sometimes the meltwater disappears into tunnels beneath the ice, flowing through dark channels you cannot see. Subglacial rivers, hidden plumbing, can be loud enough to hear as a deep, muffled roar under your feet. You stand there and you realize the glacier is not one thing. It is ice, yes, but it is also rock transport, landscape shaping, and water storage. It holds winter in its body and releases it slowly, feeding rivers long after the last snowfall, which is why so many human systems downstream depend on ice they rarely think about. Congratulations, your drinking water is sometimes just ancient snow on a very long commute. Now, let your mind drift to the coastlines shaped by glaciers, because this is where the glacier's work becomes almost theatrical. Imagine a valley once cut by a river, narrow and V-shaped. Then ice arrives and fills the valley, grinding it wider and deeper, making it U-shaped with steep sides. Later, the climate warms, the ice retreats, and the sea moves in. The ocean floods the carved valley, and what you get is a fjord. A fjord is a drowned glacial valley. It is seawater occupying a space made by ice. You float on that water now, and it feels heavy and dark, like the ocean is holding its breath. The fjord is narrow enough that the walls rise almost straight up from the water. Cliffs are streaked with runoff. Waterfalls drop in thin threads, spilling from hanging valleys above. The surface is often calm, protected from wind by the steep sides. Reflections stretch across the water, and the sky looks trapped between rock walls. It is beautiful in the way a blade is beautiful. Clean lines, sharp edges, no softness unless you count the moss clinging to stone. And beneath you, the fjord can be astonishingly deep. Deep enough that the seafloor is far below where a river would have cut. That depth is the glacier's signature. Ice can excavate far more aggressively than a river because it fills the whole valley and presses down with immense weight. At the mouth of many fjords, there is often a shallow sill, an underwater ridge left by glacial deposits. This sill can affect circulation, trapping colder water inside the fjord, shaping ecosystems, and making the water feel even more still. It is like a bathtub with a lip, holding the ocean in a narrow stone container. And sometimes, if you are near the end of a glacier that meets the sea, you hear the most honest sound in cold geography. A crack, then a boom, like distant thunder. A slab of ice breaks off and falls into the water. Calving, it sends waves rolling across the fjord, slapping against rock, rocking anything floating. The glacier just lost part of itself, and it does not care. It will keep flowing, feeding the edge, until the climate or the terrain stops it. If you stay long enough, you stop thinking of the glacier as a static object. You start thinking of it as a slow creature, shedding pieces, rearranging the shoreline, making temporary icebergs that drift and melt. And then you notice something else, how the fjord, despite its calm surface, is a kind of archive. The steep walls show layers of rock. The slopes show scars of past slides. The water holds sediment settling slowly, recording seasons like pages. Cold places preserve. That is their habit. But the moment ice lets go, the landscape becomes unstable again. Fresh slopes, newly uncovered ground, loose debris piled by retreating ice, perfect material for gravity, rain, and rivers to start their own patient work. Because ice is not the final sculptor. It is just one phase, and when the ice finally loosens its grip, flowing water moves back in like a quiet replacement contractor, less dramatic, more persistent, and fully committed to taking the long way. So, you follow the meltwater out of the cold valley into a river that does not look dangerous. It is not a raging torrent. It is just moving, always moving, carrying tiny grains you can barely see. A river does not need violence to reshape a continent. It needs time. You can think of a river as a conveyor belt for rock. Mountains are the supply. The ocean is often the destination. Everything in between is the transport route, with frequent stops, detours, and paperwork made of sediment. Upstream, near steep terrain, water has energy. It cuts, it plucks, it pries loose particles. It carries gravel and sand and silt, bouncing it along the bed, rolling it, suspending it, downstream. Downstream, where slopes flatten, the river loses energy. It cannot carry the same load, so it starts to drop what it has been dragging around. This is how floodplains form. By overflow, yes, but also by deposition, by the river painting the land with thin layers of sediment during high water. It is how meanders migrate, too. On the outside of a bend, the water moves faster, eroding the bank. On the inside, it moves slower, dropping sand. The bend grows, shifts, and eventually can cut itself off, leaving behind an oxbow lake, an abandoned curve, like a river changing its mind and leaving part of itself behind. Rivers are full of these quiet decisions. If you stand above a canyon, you might think you are looking at a wound made by catastrophe, a crack in the earth, a sudden tear. Wrong again. Many canyons are made by persistence so boring it becomes impressive. Water takes the easiest path downhill, and it keeps taking it. It carries away grains, then pebbles, then stones. It exploits small weaknesses in rock, fractures, softer layers, and it deepens its channel year after year. Even when the river looks gentle, it is doing work, especially during floods, when it has the power to move bigger material, rearranging its bed like furniture. And the canyon you see now, steep walls, exposed layers, shadows pooling in the depths, is a record of all the time the river refused to stop. Sometimes tectonics help. Land uplifts slowly, raising a plateau. The river keeps its course and cuts downward as the land rises, maintaining its path by carving deeper. This is how you get a river slicing through high terrain, not because it chose the hard way, but because the hard way rose under it. While it was busy being a river, the planet loves this kind of quiet complication. You look down into the canyon and you can almost feel the scale of time, not as a number, but as weight, layer upon layer of rock, each deposited in an old environment, an ancient sea, a river plain, a desert of dunes turned to stone, now exposed by water's patient removal. A canyon is not just emptiness, it is information revealed by subtraction. And when that river finally reaches flatter country, it begins to slow. It begins to spread. It begins to do what the Okavango does in its own inland way. Drop sediment, split channels, build new land without asking permission. At a coastline, this becomes a classic delta. The river meets the sea, loses energy, drops its load, and builds outward. Mud and sand accumulate, forming a fan of land that is always being reshaped by waves, tides, and storms. But even inland, where there is no sea to meet, rivers still have that habit. They slow in basins. They braid across gravel beds. They create alluvial fans at the base of mountains, spreading sediment like a spill. They vanish into deserts, leaving behind dry channels that only flow when rain remembers them. Rivers, in other words, are not just water. They are moving landscapes, and the most soothing part, if you let it be soothing, is that none of this requires an audience. A river will carve whether you watch or not. A delta will build and shift whether you name it or not. A canyon will deepen in the dark during storms you sleep through, During seasons you never notice, the Earth is never in a hurry. It does not do deadlines. It does not do finales. It just keeps moving material from one place to another, grain by grain, year by year, until a mountain becomes sediment, and sediment becomes stone, and stone becomes dust again. And as the water keeps moving, sometimes into sand, sometimes into sea, you can let your thoughts drift with it, downstream, toward the next bend, where the river starts to slow, where the current begins to split, where the land begins to flatten into something that looks, at first, like certainty, until you notice how easily it can change. That change starts with a tiny hesitation in the flow, a shallow bar of sand, a fallen branch, a patch of grass that decides to stand up to the current. The river is still moving, still doing its job, but now it has options. It can go left or right or both, because rivers love a loophole. You float into that widening place where the current spreads, and you can feel the energy drain out of it. Up in the canyon, the river was a worker with a tight schedule. Down here, it becomes a tired laborer dragging a heavy cart, slowing down because the ground finally stopped sloping. And as the river slows, it starts dropping things. Not dramatically, not all at once. Just a steady, quiet shedding. Coarse sand first, then finer sand, then silt so small it can stay suspended for a long time before it settles. Each grain is a tiny vote for a new shape of land. This is the part people miss because it looks like nothing is happening. But you are watching a construction site run by physics. No supervisors, no hard hats, just gravity, friction, and water losing momentum, like a shopper losing patience in a long checkout line. When enough sediment accumulates, the riverbed rises. The water becomes shallow. During the next high flow, the river spills over its banks. It does not apologize. It just takes a shortcut across the floodplain, because it can. Sometimes it returns to the main channel. Sometimes it does not. Sometimes it carves a new path, and the old path becomes a quiet backwater. Congratulations! You are looking at a landscape that redraws its own map without asking anyone. In the simplest terms, this is why a river can make a delta. It arrives with a load, it slows down, and it drops that load where it cannot carry it anymore. The shape that forms depends on what fights the river at the end. If waves are strong, they smear the sediment along the coast, flattening the delta's edges. If tides are strong, they pull channels into a branching pattern that looks like a handprint. If the river brings a lot of sediment, it can push outward, building fingers into the water. But inland, where there is no ocean to argue, the river spreads into whatever the land allows. It braids, it splits, it gets lost in its own generosity, which is how you end up back at the idea that started the night, a delta with no sea. And that is not as rare as people assume. There are other rivers that vanish too, and basins that do not drain. They are called endorheic basins, which sounds like a medical condition. It simply means the water flows inward and does not escape to an ocean. It is a closed bowl on a planetary scale. The water can leave only by evaporating or seeping underground. And because evaporation does not take salt with it, these basins often become salty over time. Lakes shrink and grow. Shorelines migrate. Salt crusts form like pale scars. You have seen versions of this in the Okavango's fringes, where minerals gather at the edges. In a fully closed basin, the same process can build entire salt deserts. The land becomes white and brittle and loud underfoot. Humans show up, see flat ground, and immediately think, excellent. Let us drive on it. That is how you learn the difference between a crust and a road. The crust breaks, the tires sink, and the landscape reminds you it was never designed for your convenience. But even where rivers do reach the sea, deltas are not stable gifts. They are bargains. They exist only as long as sediment arrives faster than the ocean can steal it back. If a river is dammed upstream, sediment gets trapped in reservoirs, and the delta downstream begins to starve. The river still brings water, but it brings less building material. Waves and currents keep working, and the delta can start to retreat. Land that took thousands of years to build can erode in a human lifetime. That is one of the quieter tragedies of modern geography. We love controlling rivers because rivers are inconvenient. They flood, they wander, they ignore property lines. So we straighten channels, we build levees, we trap water behind concrete, and then we act surprised when the coastline changes. A delta is not land in the solid, confident sense. It is wet sediment, freshly delivered. It is a place that is still thinking about becoming rock and has not committed yet. It compacts slowly. It sinks under its own weight. If sea level rises, it struggles to keep up unless the river keeps feeding its sediment. So the very thing that makes a delta fertile also makes it precarious. Rich soils, easy access to water, flat ground for building, and a surface that can subside in flood, especially when storms arrive. Congratulations, you found a great place to farm and a terrible place to assume permanence. Even in the Okavango, where the ocean is not the enemy, water still negotiates with land. The channels shift, the islands expand, the salty edges grow and retreat with the seasons, and the whole system depends on distant rainfall, arriving on delay like a slow message that could change its mind. If you zoom out again, you can feel the planet's habits repeating. Water spreads when slopes are gentle. Water concentrates when slopes are steep. Water disappears when heat and dry air are patient enough. And sometimes, water does something even stranger. Sometimes, instead of flowing on the surface, it vanishes into the ground entirely and travels in darkness for a while. Not as a hidden river under ice, but as groundwater moving through stone. This is where the geography turns into a quiet maze. You step into a landscape that looks ordinary at first. A green valley maybe, with scattered trees, a line of hills, a stream that chatters over pebbles, doing its friendly river impression. And then the stream reaches a crack in the limestone and simply drops out of sight. No drama, no warning. One moment you have water, the next moment you have a dry channel, and the sound is gone. The land has swallowed it. This is karst, which is a word for landscapes built from dissolving rock. Limestone, dolomite, gypsum, stones that can be eaten slowly by slightly acidic water. Rainwater becomes mildly acidic when it absorbs CO2 from the air and soil. It turns into a weak carbonic acid. Not enough to burn your skin, but enough to dissolve limestone over long periods. It is slow chemistry. and it changes everything. Water finds tiny fractures in rock. It seeps in. It dissolves the edges. The fractures widen millimeter by millimeter until they become channels. Channels become caves. Caves collapse sometimes, creating sinkholes. Entire regions develop underground drainage systems that ignore the surface entirely. You can walk across a karst plateau and see no rivers at all because the water has taken its work indoors. It runs through caves and conduits, moving where you cannot follow without a helmet and questionable life choices. Above ground, karst can look like a place that has been gently ruined. The soil can be thin because water drains away quickly. The surface can be pocked with holes. Some are small depressions. Others are deep shafts, openings into darkness where cold air leaks upward. If you stand near one, you can feel that chill on your ankles. It is the earth exhaling from its hidden rooms. And if you listen, you might hear water far below, running through stone like a secret. It is the same water cycle, just taking a less scenic route. People have built towns on karst because the ground looks stable enough. Then a sinkhole opens and a street folds into the earth like paper. It is not common everywhere, but it is common enough that some regions live with quiet anxiety. The problem is that karst collapses do not always give polite warnings. A cavity grows underground, the roof thins, and one day the weight above becomes too much, and the land does what it always does. It adjusts. You are reminded again that solid ground is often a suggestion. Karst also makes springs, which can feel like magic, but are really just plumbing. Water travels underground, sometimes for long distances, then emerges where the geology allows it. A crack meets the surface. A layer of impermeable rock forces the water out, and suddenly, a river begins at a hole in the ground, clear and cold, as if it was manufactured. Some springs are gentle. Others are powerful enough to form immediate rapids, pushing out thousands of liters per second, like the earth is running a tap. In dry regions, these springs become oases, and humans gather around them like moths around a porch light. They build farms, villages, rituals, and arguments over who owns the source. But springs can fail too. If groundwater levels drop, the pressure decreases. The flow weakens. The water that seemed eternal becomes seasonal, then occasional, then memory. So even underground water is not a promise. It is a balance. And balance is a good word to hold on to because it keeps showing up wherever you look. In deltas, in fog deserts, in glaciers, in karst, in every system where a little change in input can reshape the whole outcome. Now, if you want a place where water and rock have been negotiating for an absurd amount of time, you can drift to a cave. Not a horror movie cave, a real cave with slow drips and patient mineral growth. You step inside and the temperature steadies because caves are good at ignoring the weather. Outside might be summer or winter or wind. Inside is the same cool, damp calm because the earth is a better insulator than any house you have ever lived in. You hear dripping first, a rhythmic plink, 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 like a clock that measures time in drops instead of seconds. That drop carries dissolved limestone. When it reaches the cave air, it loses some CO2, and the calcium carbonate precipitates out. A tiny ring of mineral remains. Over time, that ring becomes a stalactite hanging from the ceiling. On the floor, where the drops land, stalagmites grow upward. If they meet, they form a column connecting ceiling and floor like a slow, mineral handshake. These structures grow at rates that make impatience look ridiculous. Millimeters per year, sometimes slower. You could visit the same cave your entire life and not notice a difference. But over thousands of years, the cave becomes decorated in stone that used to be dissolved in water. The cave is built from absence, carved by dissolution, then filled again by deposition. That cycle is comforting in a strange way. The earth takes away, then gives back, never hurrying, never explaining itself. And in some caves, you find underground rivers, still moving, still dissolving rock, still changing the system as you stand there listening. These underground networks can connect entire regions. They can feed springs and wetlands far away. They can transport contaminants quickly too, because karst drainage is fast. Water does not filter through soil the way it does in other aquifers. It moves through conduits like a subway, carrying whatever it picks up. So, a spill on the surface can show up in a spring kilometers away, surprising everyone who assumed the ground would clean it up. The earth is not always the gentle purifier people imagine. Sometimes it is just a shortcut. Speaking of shortcuts, rivers sometimes create their own in the most dramatic way. And you do not even need karst for it. You just need a meander that gets too ambitious. Picture the river looping, bending, exaggerating its curves across a floodplain. The outside banks erode, the inside banks build up. The loop narrows at the neck until two sections of river are separated by a thin strip of land. Then a flood arrives. The river overtops its banks, flows across the neck, and finds the shorter route. The loop is cut off. The main channel straightens. The old curve becomes an oxbow lake, a crescent of still water left behind like a discarded thought. Over time, that oxbow fills with sediment and plant matter. It becomes a marsh, then a damp meadow. Then, if you blink across a century, just a faint depression that tells you the river used to be somewhere else. This is how rivers travel sideways without ever meaning to. This is how floodplains migrate. This is how maps become outdated. Humans respond by building levees, trying to freeze the river in place. It works for a while, until the river finds another weakness, or the levees fail, or the sediment builds the bed higher, and the water rises above the land like a quiet threat. The more you constrain a river, the more you turn it into a problem that must be continuously managed. A wild river spreads its risk across a floodplain. A controlled river concentrates its risk into one channel and then pretends it can hold that risk forever. It is a bold strategy, and the planet enjoys watching it. Now, if you step back again, you can see the big loop that ties all of these places together. Water moves material. Ice moves material. Wind moves material. Gravity moves material. The shapes you admire are temporary solutions to ongoing forces. Even the hardest mountains, the ones that look eternal, are being dismantled grain by grain. The only question is where the grains go next. Sometimes they go to a delta. Sometimes they go to a sand sea. Sometimes they go to the deep ocean, settling into layers that might become rock again, if the tectonics cooperate. and tectonics always want to cooperate. Eventually, they are slow, but they are not optional. You cannot talk about rivers and deltas for long without admitting the uncomfortable truth. The land itself moves, continents drift, basins form, mountains rise, sea levels change. Rivers adjust to all of it the way water always does, by following gravity and exploiting weakness. So while you are imagining the calm of the Okavango, remember there is a deeper engine under it. The basin exists because of tectonic structures, faults, and subtle warping of the crust. Southern Africa is relatively stable compared to some regions, but stable is a relative word. It still has faults. It still flexes. It still responds to deep forces. In the Okavango, there is a rift system, an area where the crust is being gently pulled and fractured, not ripping apart like a dramatic continental breakup, but adjusting enough to influence where water collects and how channels shift. That means the delta is not only a product of water and sand, it is also a product of the Earth's slow stretching and settling. The land provides the bowl, the river provides the water, the sun provides the exit. Three partners in a long, quiet arrangement. Now, let your mind drift back over the delta again, but this time in daylight. The water is no longer black. It is tea-colored, stained by plant matter, reflecting sky. The reeds are tall and pale green. The papyrus stands like thick brushes. Islands are darker patches, shaded by trees. You glide in a mokoro, a dugout canoe, low to the water. The motion is smooth, almost too smooth, and the silence is broken only by insects and distant birds. This is the kind of scene that makes people say, peaceful. And it is. But it is also a working landscape, full of quiet hazards. Hippos, for example, are not part of the calming marketing, but they are there. They are mostly submerged, looking like rocks that breathe. They are territorial, and they move fast when they choose to. The delta's channels can be narrow, and a large animal in a narrow channel becomes a negotiation. Crocodiles, too, treat water like a waiting room. They do not need to chase constantly. They can be still and let physics bring food near their mouths. So yes, the delta is gentle, but it is gentle the way a sleeping dog is gentle. You do not poke it without a reason. Humans live around the delta and have for a long time, adapting to its rhythms. Communities in Botswana have used the delta's seasonal changes for fishing, grazing, and transport. When the flood arrives, certain routes open. When it retreats, others become possible. The delta becomes a calendar you can travel on. But modern pressures exist here too, because of course they do. Water upstream is not guaranteed. Climate variability affects rainfall. Land use changes can influence runoff, and any alteration in flow can ripple through a system that depends on timing. It is hard to manage a delta because a delta is not a single thing. It is a network of channels, islands, floodplains, and chemical gradients held together by movement. You cannot freeze it without breaking it. And there is another quiet truth about inland deltas and wetlands. They act like filters and sponges. They trap sediment. They absorb nutrients. They slow water, reducing floods downstream. They recharge groundwater. When wetlands disappear, the water cycle becomes sharper, more extreme. Floods get flashier. Droughts get harsher. Water quality declines. The landscape loses its ability to buffer. A wetland is a kind of patience made physical. So when you drift through the Okavango, you are not just seeing scenery. You are seeing a functioning system that moderates extremes in a dry region. You are seeing a place that holds water just long enough to matter. Now, hold on to that idea of moderation, because it is also what fog does in the Namib. It is a small, steady input in a place that otherwise would be even harsher. It is not enough to change the desert into a forest. It is enough to make survival possible for specialists. And glaciers, in their own cold way, also moderate. They store water as ice, then release it during warm seasons. Downstream ecosystems and human agriculture can depend on that predictable melt. When glaciers shrink, that moderation changes. At first, meltwater can increase because more ice is exposed. Rivers run higher, and it can feel like extra supply. Then the glacier mass declines further, and the long-term storage disappears. The river becomes more seasonal, more dependent on immediate precipitation. It is like spending savings. At first, you feel rich. Later, you realize the account is empty. Geography is full of these delayed consequences. And since we are staying with slow, delayed truths, it is worth lingering on how rivers remember their past, even when they look calm. A river's floodplain is built from older floods. Each layer of silt is a record of a time the water left its channel. If you cut into a bank, you might see thin bands, slightly different colors, slightly different grain sizes, stacked like pages. Some pages are written in big flood years, others in quiet years. Over time, the floodplain becomes a history book, the river authored without ever learning to read. In deltas, that layering becomes even more complex. Channels shift, sediment fans out, organic matter accumulates in wetlands. Over long periods, those deposits can become thick enough to compact into sedimentary rock. So, the delta, which looks like soft mud now, could become stone in the deep future, and that stone could be uplifted, exposed, and carved again. This is the part of geology that is both soothing and slightly insulting. The earth recycles landscapes. The place you worry about today will someday be a layer in rock, and the rock will someday be sand again. The planet does not hold grudges. It barely holds shapes. Now, imagine yourself not as a person drifting on a river, but as one grain of sand. You started high in a mountain, locked inside rock. Maybe you were quartz, stubborn and hard. A freeze-thaw cycle cracked the rock. Water seeped into the fracture, froze, expanded, and pried the stone apart. Gravity pulled you down slope. A stream caught you and bounced you along its bed. You scraped other grains. You got rounded. You became less jagged, more polite. You traveled through rapids. You rested in a quiet pool. You were picked up again during a flood. You were dropped on a bar. You sat there in the sun for a year, then a storm took you again. Eventually you reached flat land. The river slowed. You settled not because you wanted to stop, but because physics said you were done for now. You became part of a sandbank, then part of an island, then part of a floodplain soil where plants rooted above you. For a while, you were stable. But stability is just slow motion movement. A channel shifted, water returned. Your patch eroded. You were picked up again, carried into a different channel, and dropped at the edge of a lagoon. Then the dry season arrived. The water evaporated. Salt traces accumulated nearby. Plants changed. Animals changed. The chemistry shifted around you. You lay in soil that cracked under heat, then softened again when the flood returned months later. You were always in motion, even when you looked still. If you stayed in that basin long enough, you might sink, buried by more sediment. Compaction pressed you tighter. Minerals cemented you. You became sandstone, a new rock made from old fragments. And if tectonics lifted that sandstone someday and wind and water eroded it, you could become sand again. Congratulations, you are trapped in the world's slowest washing machine. This grain of sand perspective is not just poetic. It is literally how landscapes evolve. Movement of sediment is the language rivers, wind, and ice use to talk to the planet. Now, wind deserves its own quiet respect because it is another patient sculptor that works best where water is scarce. In deserts, wind can become the main mover of sediment. It picks up fine grains, carries them in suspension, and drops them when the wind slows. It pushes sand along the ground in short hops called saltation, which sounds like something you do at a dance class. It means grains bouncing, tapping the surface, knocking other grains loose. Over time, that creates dunes, ripples, and sand seas. Dunes can align with prevailing winds, forming long ridges. They can form star dunes, where winds come from multiple directions, piling sand into tall pyramids. But dunes are not just piles. They are moving forms, migrating over years and decades. They can swallow roads. They can bury fences. They can fill valleys. If you build in their path, you are not stopping them. You are volunteering to be part of their story. Wind also sorts sediment by size. Fine dust can travel far, sometimes across continents. Sahara dust, for example, can cross the Atlantic and fertilize the Amazon. Nutrients from African soils end up feeding South American forests. So even deserts, which look like empty places, can have global influence. They export minerals as airborne packages. The Namib's dunes, too, are part of a long sediment system. Sand can be delivered from rivers to the coast, then moved northward by currents, then blown inland by wind. The desert is not isolated. It is connected to ocean and river systems through transport. Everything connects, eventually. And if you want a place where wind and water both show their work in the same frame, you can think of a coastline. Coasts are where land meets a restless boundary. Waves arrive with energy generated far away by storms. They break on shore, moving sand along the coast in a process called longshore drift. Beaches gain and lose sediment depending on currents and storms. Coastal dunes form when wind picks up beach sand and deposits it inland, building ridges that can protect the interior from salt spray and waves. But again, protection is temporary. Storm surges can cut through dunes. Sea level rise can push the shoreline inland. Human development can trap sand and starve beaches. A coastline is never finished. It is always negotiating. Speaking of negotiation, there is a particular kind of coastline that looks calm until you understand what built it. Barrier islands. They are long, thin strips of sand running parallel to shore, separated from the mainland by lagoons or marshes. They exist because waves and currents pile sand in a certain way, and because sea level and sediment supply find a temporary balance. Barrier islands move. They migrate landward over time, rolling like slow caterpillars as storms erode their ocean side and deposit sand on their landward side. People build houses on them anyway, because humans have a special talent for misunderstanding temporary landforms. Then a hurricane arrives, cuts an inlet, rearranges the island, and places someone's living room in the ocean. And afterward, we say it was unexpected. Geography is rarely unexpected. It is just ignored until it becomes expensive. Now, let us drift back inland again, away from coasts and into the interior systems where water can vanish. Closed basins, inland deltas, deserts. These are places where water does not get an easy exit, so it behaves differently. It spreads, it evaporates, it becomes salty, it sinks. And that is why the Okavango feels like a miracle. It is water insisting on being visible in a region that prefers to hide it underground or send it back to the sky. The delta's fan shape is not static either. Over centuries, it can shift east or west depending on channels and sediment buildup and on subtle tectonic movements. Some parts become more active, others dry and become grassland. Then the pattern reverses later. So if you return after a long time, the delta will still be there, but not exactly where you remember it. Familiar lagoons may have shrunk. New channels may have opened. Islands may have grown or been eroded. The delta remains a delta by changing constantly. That is another one of those calm paradoxes. Now, while you are still drifting in this idea of shifting water paths, it is worth noticing how little height difference it takes to control a whole landscape. In the Okavango, a difference of a few centimeters can decide whether an area floods or stays dry. A termite mound can become an island simply by being slightly higher than its surroundings. A sediment ridge can divert flow, sending water into a new channel. In flat landscapes, microtopography becomes destiny. That also means that small changes, like plant growth or sediment deposition, can have outsized effects. Reeds slow water, causing sediment to settle, raising the bed, pushing flow elsewhere. Vegetation is not just decoration, it is infrastructure. In that sense, the delta is co-built by plants. Papyrus and reeds trap sediment. They stabilize banks. They create friction that slows water. They help define channels. In return, the water delivers nutrients and keeps competition from dry land species at bay. It is a slow partnership, and it shapes the map. And when fire enters the story, which it often does in savanna regions, the mosaic shifts again. Dry season fires can clear old vegetation. New growth follows. The timing of flood and fire creates patterns of habitat. So the delta is not just hydrology. It is ecology, sediment transport, chemistry, and climate, all layered together. You do not have to memorize that. You just have to feel how complex a quiet place can be, because quiet does not mean simple. Quiet often means slow. Now, since we have drifted through water systems that spread out and vanish, it is only fair to linger on water systems that do the opposite, that concentrate, tighten, and cut down fast. Flash floods in dry lands. You stand in a dry channel, a wadi, a wash. The bed is sandy, scattered with stones. It looks harmless, like a path. The sky overhead is clear where you are, and that is the trick. Rain can fall far upstream. In hills, you cannot see. The dry soil cannot absorb it quickly. Water runs off in sheets, gathers in gullies, converges into channels, it accelerates, it carries debris. Then it arrives where you are as a sudden wall of brown water, full of sticks, rocks, and the pieces of the landscape it tore loose. People die in these floods because the channel looked dry, because the storm was somewhere else, because water is capable of arriving late and fast at the same time. In a way, it is the violent cousin of the Okavango's delayed flood. Same principle, different temperament. The Okavango's flood arrives slowly because the basin is flat and broad, and the water spreads out. Flash floods arrive fast because the terrain is steep and the water concentrates. This is the same physics wearing different clothing. And those flash floods do geomorphic work too. They scour channels. They transport boulders. They carve gullies. In deserts, rare water can do a lot of shaping because vegetation is sparse and soils are loose. So even in places that are dry most of the year, water still matters. It just shows up in short, intense episodes, like an uninvited guest breaking furniture. Now, if you want a truly patient kind of water shaping, you return to ice again, because glaciers are the slowest version of a flood you can imagine. But we already stood near crevasses and fjords. So instead, let us follow the meltwater farther downstream, into the place where glacial sediment becomes new land. Outwash plains. When glaciers melt, they release not only water, but also piles of sediment they carried. Meltwater streams braid across broad plains, splitting and rejoining because the sediment load is heavy and the channels constantly clog. These braided rivers are wide, shallow, and restless. They are like the Okavango's channels in a hurry, constantly shifting because the bed cannot stay stable under the moving load. If you stand above a braided river, it looks like silver threads on gray gravel. Islands appear and disappear. The flow reorganizes after every flood. These plains can extend far from the glacier front, building large deposits of sand and gravel. Over time, those deposits can become terraces, raised steps in the landscape that mark former river levels. So, the glacial system leaves behind not only carved valleys and moraines, but also spreads of sorted sediment that become the foundation for future soils, future forests, future towns. People like building on gravel terraces because they are flat and above flood levels. Then the river changes course, and the terrace is no longer safe, or groundwater behaves differently than expected, or the gravel shifts in an earthquake. The earth is always ready with follow-up problems. Now, speaking of earthquakes, it is worth remembering that rivers and deltas are often influenced by tectonic events in sudden ways. An earthquake can uplift a riverbed, creating a waterfall overnight. It can drop land, creating a new lake. It can trigger landslides that dam rivers, forming temporary reservoirs that can later fail catastrophically. In deltas, earthquakes can cause liquefaction, where water-saturated sediment temporarily behaves like a liquid. Buildings tilt, ground cracks, the surface loses its firmness. Liquefaction is the Earth's way of reminding you that sand is not rock. It is just rock that has not committed yet. This matters in delta cities around the world. Many major urban areas are built on deltaic sediments because deltas are fertile and accessible. But those sediments can amplify shaking during earthquakes, and they can liquefy. The risk is built into the ground. Humans prefer to blame disasters on bad luck. Often it is just geology being itself under a crowded schedule. Now, bring your attention back to the Okavango one more time. Not as a place of animals and safari stories, but as a hydrological puzzle that keeps working because of gradients so small you can barely imagine them. The water enters at the panhandle, the narrow northern part where the river is still more river-like. Then it spreads into the fan, splitting into distributaries, which is the formal term for channels that branch off from the main flow in a delta. Distributaries are the opposite of tributaries. Tributaries feed a river. Distributaries bleed it outward. In coastal deltas, distributaries carry sediment to the sea. In the Okavango, they carry water across the floodplain until it evaporates or infiltrates. Because the land is so flat, blockages matter. Floating vegetation can form mats. Fallen trees can redirect flow. Even animals can influence channels by trampling banks or creating paths that become flow routes during floods. So the delta is a living hydraulic system, sensitive to small disturbances. Over time, some channels become less active as sediment accumulates. Others become more active as flow is redirected. The system oscillates, not in a neat pattern, but in a dynamic equilibrium. That phrase, dynamic equilibrium, sounds like a corporate slogan. It means the system stays roughly the same overall, while constantly changing in detail. It is stability through motion. It is how the delta survives. Now, let us widen our lens to the Kalahari again, because the delta's existence inside a sandy basin is part of a broader category of weird geography. Wetlands that appear where you do not expect them. There are other inland wetlands fed by rivers that do not reach the sea. The Sud in South Sudan is a huge swamp where the White Nile spreads out, losing water to evaporation and vegetation. It is another place where a river slows down and becomes a broad, breathing system. In Central Asia, rivers that feed the Aral Sea once sustained a large inland lake, but diversion for irrigation reduced inflow, and the sea shrank dramatically, leaving behind salty flats and stranded fishing ports. A water body that seemed permanent revealed its dependence on inflow. In the western United States, the Great Basin contains many endorheic areas where water collects in salt lakes or dries into playas. During wet periods, lakes expand. During dry periods, they retreat, leaving dust that can blow far. So the pattern repeats globally. Where drainage is closed, water accumulates and disappears in ways that create strange landscapes. Okavango is special because it remains a functioning, biodiverse wetland system in a dry region, with relatively limited upstream modification compared to many other basins. It is a rare case of a large inland delta still behaving like itself, which makes it valuable and also vulnerable, not fragile like glass, vulnerable like a balance beam. A shift in rainfall patterns, a change in upstream land use, increased water extraction, any of these can tilt the system. But for now, in this imagined drift, the water is still arriving late, still spreading, still feeding reeds, still leaving minerals behind at the edges like a faint signature. And that brings you back to the strange intimacy of water that vanishes. Because when a river reaches the ocean, you can imagine its endpoint. When a river vanishes into sand and sky, the endpoint is distributed. It is everywhere and nowhere. Some molecules rise into the air and travel as vapor, perhaps to fall as rain somewhere else weeks later. Some seep into groundwater and move slowly beneath the desert. Some stay in plants and are transpired back to the sky. Some remain in pools long enough to support fish and insects and birds. So the river does not end. It just changes form and location, which is the real geography lesson, if there is one. Water is not an object. It is a phase shifter. It moves between states, between places, between time scales, always taking the route allowed by physics. And humans, with all our planning, are just one more obstacle it flows around. Now, if you let your thoughts follow vapor upward, you can imagine the larger atmospheric patterns that decide where water falls in the first place. The tropics receive intense sunlight, heating air, causing it to rise. Rising air cools, moisture condenses, rain falls. That is part of why equatorial regions can be wet. Farther from the equator, descending air tends to be dry because it warmed as it sank, and warming air can hold more moisture without condensing. Those descending zones often align with deserts. So deserts are not accidents. They are part of circulation. The Hadley cell is the formal term for this tropical atmospheric circulation. It sounds like a prison block. It is simply a large-scale pattern of rising and sinking air. The Namib sits in a region influenced by descending dry air and a cold ocean current, which stabilizes the atmosphere and discourages rain, so the desert persists. Fog becomes the workaround. The Okavango sits farther inland, influenced by seasonal rainfall patterns in its source region and by the basin shape that holds water. Everything is connected, again, through circulation and topography. If you wanted to be truly sleepy about it, you could imagine the planet as a set of slow conveyor belts. Ocean currents moving heat, wind patterns moving moisture, rivers moving sediment, glaciers moving rock, tectonic plates moving continents. You are always riding something. And sometimes you are riding something so slow you forget it is moving until you look back and realize the landscape has changed. Now, let us return to rivers one more time, because rivers have one more trick that is easy to overlook. They can be older than the mountains they cut through. This happens when a river establishes its course on relatively low relief terrain, and then tectonic uplift raises mountains across that course. If the uplift is slow enough, the river can maintain its path by cutting down as the land rises. This creates a water gap, a gorge slicing through a ridge, which looks like the river chose the hardest route on purpose. It did not. The ridge arrived later, like an inconvenient renovation. This is called antecedent drainage, which sounds like a family history problem. It means the river's path is older than the topography. So when you see a river cutting through mountains, do not assume the river is brave. Assume the river is stubborn and was there first. That is comforting in its own way. Persistence beats obstacles, given enough time. And that brings you back to canyons, because canyons are often the product of a river maintaining a course while land rises, or while sea level drops, increasing the river's ability to cut downward. When sea level drops, rivers can incise, cutting deeper to reach the new base level. When sea level rises, rivers can deposit more sediment, building floodplains and deltas. So, global changes in sea level, often driven by glacial cycles, can influence river behavior far inland. During ice ages, sea level can be lower because more water is stored in ice. Rivers then cut deeper valleys. When ice melts and sea level rises, those valleys can flood, becoming estuaries. Fjords are one example of flooded valleys, but river valleys can flood too, creating drowned river mouths, tidal inlets, and complex coastlines. So, the ice story and the river story braid together. And now, as the water story keeps braiding, you notice the pattern across all these weird geographies. Timing matters as much as amount. The Okavango's flood arrives months after rain fell. The Namib's moisture arrives daily as fog, then vanishes. Glacial melt arrives seasonally, depending on temperature. Flash floods arrive suddenly, triggered by distant storms. Springs can flow steadily for years, then change if groundwater levels shift. Time and water are partners. Humans want water on demand. Geography offers water on schedule, and the schedule is not negotiable. And that is why so many cultures built their calendars around floods and rains. The Nile's flood season once organized agriculture. Monsoon timing organizes planting across South Asia. Snowmelt organizes water management in mountain-fed basins. When timing shifts, everything downstream feels it. So when you lie here listening to a story about deltas and fog deserts, you are also hearing about how the planet sets terms. It delivers resources, but not on your preferred timeline. Now, you can let your mind wander to another slow geography that is built by water arriving late, not as a flood, but as rain that falls on a plateau and takes its time leaving. Highland bogs and peatlands. In cool, wet regions, waterlogged soils can slow decomposition. Dead plant material accumulates faster than it breaks down. Over centuries, that material forms peat, a dark, spongy soil that holds water like a memory. Peatlands can store enormous amounts of carbon, locked away because the saturated low oxygen conditions slow decay. When peat dries, it can burn, releasing that stored carbon and creating fires that smolder underground. Peat fires are the kind of geological horror that does not look dramatic at first. The ground smokes, the fire creeps slowly through soil. It can persist for months. It can survive winter under snow. It can re-emerge later. It is fire behaving like a glacier, and it is unsettling. Peatlands also influence hydrology. They release water slowly, moderating floods and maintaining stream flow during dry periods. Like wetlands, they buffer extremes. So, again, the theme repeats. Landscapes that hold water are not just pretty, they are functional regulators. And when they are drained for agriculture or development, the system loses that regulation. Streams become flashier, water quality changes, carbon storage is released. The planet keeps accounts, even if we pretend it does not. Now, before your mind drifts too far into peat smoke, come back to a simpler image. Water moving through reeds, through channels, through a flat basin that turns a river into a fan. Think again of how a delta is built, not by one grand action, but by repetition. Flood after flood, sediment layer after sediment layer, channel shift after channel shift. The delta is the sum of many small moments. That is the most calming part of geography. if you let it be, landscapes are not usually made by single events. They are made by accumulated ordinary processes. Even volcanoes, which seem dramatic, spend much of their time quietly building layers. Lava flows cool, ash settles, erosion shapes the cone between eruptions. Then, once in a while, the volcano reminds everyone it is not scenery. But we do not need to climb onto a volcanic rim right now. That would wake you up. Instead, stay with the river's slow spread and consider what happens to the finest sediment, the silt and clay that can travel far. In calm water, clay particles can take a long time to settle because they are so small. In wetlands, those particles can settle onto plant surfaces, onto floodplain soils, into quiet backwaters. Over time, that fine sediment can create fertile soils because it holds nutrients and water better than coarse sand. This is why floodplains are often rich agricultural lands. But fine sediment also makes mud, and mud is an underappreciated hazard. Vehicles sink, footsteps become labor. Structures built on muddy ground require foundations. In deltas, the ground can be so soft that heavy buildings cause subsidence. So the same richness that draws humans in creates engineering problems. Fertility comes with instability. Geography loves trade-offs. In the Okavango, the fertile zones support lush plant growth and complex food webs. But human settlement inside the delta is limited partly because of flooding, wildlife, and the shifting nature of channels. Instead, people tend to live on the margins, on higher ground, using the delta as a resource landscape rather than a dense urban platform. That is adaptation to the delta's personality. In other deltas, like the Ganges-Brahmaputra or the Mekong, population density is high, and the stakes are higher when the delta shifts. Sea level rise, subsidence, and storm surges become existential problems. So, the Okavango is both a wonder and a warning. A functioning inland delta that shows what water can do when allowed to spread, and what humans risk when they build as if spread and shift will stop. Now, let your thoughts slip back into the channel again, where papyrus crowds the edges and the water is shaded. The surface is dotted with lily pads in places, broad leaves that float like small rafts. Under them, the water is cooler. Fish hide in the shade. Insects skate on the surface tension, which is a real physical phenomenon, not a poetic one. Water molecules cling to each other, creating a skin that can support tiny bodies. It is a small-scale miracle, and it happens everywhere, but you notice it more in still water. Surface tension is why droplets form. It is why dew beads on leaves. It is why fog droplets can cling to desert plants. It is why small insects can walk on water like they are disrespecting gravity. Gravity, of course, will have its revenge eventually, but it lets the insects have their moment. And as you drift, you pass the edge of an island where the water meets dry ground. The soil here is darker, richer, built from years of plant litter and sediment. Roots knit it together. The island is a patch of stability, but even it is temporary on long time scales. If the channel shifts away, the island may dry more often, and different plants may take over. If the channel shifts closer, the island may erode, or become smaller, or split, so even islands which feel like anchors are part of the flow. That is the core truth you keep circling tonight. Nothing is fixed, only slow. And since the story is still flowing, you can keep following it into the next quiet oddity. The way water, when it has nowhere to go, can turn landscapes into mirrors that vanish overnight. Playas, salt flats, ephemeral lakes. In arid basins, rain may fall rarely, but when it does, water can collect in shallow depressions. A lake forms, thin and wide. The surface reflects sky so perfectly, it feels like a portal. Then the sun arrives and the lake evaporates. The water disappears. The salts remain. The lake bed dries into polygon cracks. Wind lifts dust. The mirror is gone. These ephemeral lakes can be beautiful and deceptive. People walk out onto them, thinking the surface is solid. Sometimes it is. Sometimes it is a thin crust over mud that will swallow shoes, and dignity, and occasionally vehicles. The polygons form because mud shrinks as it dries. Cracks open, dividing the surface into tiles. The edges curl slightly. Over time, repeated wetting and drying can reinforce the pattern. In salt flats, crystals can grow on the surface, forming a crunchy crust. Salt can also move upward through capillary action as groundwater evaporates near the surface, leaving mineral deposits behind. So again, evaporation writes on the land. This connects back to the Okavango's pale edges, where minerals accumulate as water leaves. It is the same process scaled up in a more closed system. And now, without rushing, you can feel the loop closing between all these places: the inland delta, the desert fog, the glacier-carved fjord, the canyon, the salt pan. They are all expressions of water moving, changing state, moving material, and leaving traces. The earth is a record of fluids, not just water, but also air and molten rock, and even the slow creep of solid ice behaving like fluid under pressure. Everything flows, given time, and that thought can carry you forward into the next stretch of the journey, where the river's patience becomes the land's patience, and the land's patience becomes a kind of quiet indifference you can almost lean on, because there is always another basin, another channel, another